And now we're back again. It's our last discussion of logic for this fall. And for this last discussion, I'd like to do something that most of my recorded comments have not really done very much, and that is to bring the logic that we're doing back toward philosophical questions and philosophical conversations. You know, one justification that's given for the study of logic is sort of like what people used to say in the old days about studying geometry. They used to say if you study geometry, you can think more reasonably. I don't know whether that's true. I think if that's true, it's certainly true of logic, but not so much the logic that emerges when we do proofs according to rules of inference, for example, or according to trees. Rather, the clear thinking that philosophy trades on emerges in the study of logic in that move when we go from the natural language to the logical language. We start with a certain, really quite small vocabulary or syntax. Even for predicate logic, we have predicates or properties, we have a few logical connectives, and we have two quantifiers. And the effort becomes how to fit quite ordinary, meaningful locutions into this logical vocabulary. And the advantage is that we understand better what true statements or truth conditions we're actually committed to in our quite ordinary natural language statements. Now, I already went on about that phenomenon a couple of sessions ago when looking at the move toward predicate logic. How astonishing it was, for example, to find that some dogs are mammals and all dogs are mammals, although in English and in many languages, they appear to have the same fundamental grammar. Once translated into logic, they turn out to have really almost not incompatible, but clearly distinguishable grammatical structures, conditional in one case, conjunction in the other. But even there, at least, you would have the single verb of some dogs are mammals translate into the single logical connective of conjunction. What we're looking at in this final session is a set of natural language locutions that don't go over into logic in quite the same simple way, where there's one natural language locution and one corresponding logical locution. Concepts like except and it's related only, at least this many, at most this many, exactly this many. And of course, the crowning achievement, the, turn out not to correspond word for word with anything in logic. So it's sort of like when you're learning a language that's very similar to your own, you can almost go back and forth and, oh, you know, they say chapeau, we say hat. But there are certain languages that are further apart from your native language for which there might not be a corresponding entity at all. A particle, for example, might occur in one language that corresponds to nothing in another language, or else corresponds to really quite roundabout locution in the other language. That's how it is when we go back and forth between a natural language like English and the language of logic. In all these cases, what the locutions we're looking at today have in common is that they need some kind of identity to make them possible. And so we're going to start by looking at identity and then and then determine what this identity relation lets us do. Okay, then. Identity is a two-place relation. It's a two-place predicate. Okay, we've been using one-place predicates all semester, or when we've been doing predicate logic. Is red, is a candidate, is a millionaire. Those are one-place predicates. Identity is a two-place predicate. Now, there are many two-place predicates, often called relations. Identity is a specific one, such that it is true of any object and itself, and it's false of any object and something that's not the same object. It holds of any object with itself, and it fails to hold of any object other than itself. Okay. We use the equal sign, equals, to write, for example, A is A, this is this, A is not B. It's just the equal sign with a slash through it, right? Something is not identical to something else or is different from. Now, the superficial resemblance between identity and the biconditional could lead people astray. Please do not take identity to be a logical relation. It's not a logical relation, and it doesn't hold between sentences at all. It's an assertion about the relationship between two names. So instead of the equal sign, for example, we could have had the capital letter I, and to write that A is identical with B, we would have written lowercase a, capital I, lowercase b, just as we would write with any two-place predicate, okay? It's not a logical relationship, it's a material relation that holds between objects. Okay. Now that we have identity in hand, and it's pretty simple to explain what identity is, we can begin to analyze such concepts as except and only. Except. Everyone liked the music except me. If you're not me, you like the music. So everyone who is not identical with me liked the music. Now, that's a little too fast because everyone except me liked the music, although it doesn't overtly say so in English, does carry the implicature that I did not like the music. Logically, you might say it doesn't have to mean that, right? Everyone but me liked the music. I'm sure I would have liked it too. I don't know. Once in a while, we come across a locution that can use except and not mean that, as in this case, I don't like the music. But for the most part, the ordinary use of English or another natural language treats except as indicating that the opposite is true. Okay, so for example, suppose you park somewhere in New York City and there's a street sign that says no parking except on Saturday. Well, it's Saturday, so you park and you get a ticket, and you go in to challenge the ticket, and you say, see, it was a Saturday and it said no parking except on Saturday. Now, I think we would be very much taken aback if the traffic court said, oh, well, it says no parking except on Saturday. You certainly cannot park on non-Saturday days. However, that does not assert that you can park on Saturday. It's rather the law is silent on that subject. Well, I think we would take that statement amiss. No parking except on Saturday clearly suggests, implies, leads you to believe that on Saturday you can indeed park. Okay. Same thing with a sentence like, everyone except me like the music. It clearly and logically asserts that everyone not identical with me like the music, but it also, unless the contrary is spelled out, it also tells you that me, everyone identical with me, that is to say me, failed to like the music. Let's take a look at what this is supposed to say. Everyone liked the music except me. And as I put in parentheses, and I did not. Okay, so for all x, if x was not identical with me, we can annotate this. If x was not identical with me, then x liked the music. And by the way, or additionally, we can assert I failed to like the music. It's not the case that I like the music. Notice, incidentally, these parentheses that come after the quantifier end with Lx. For all x, if x was different from me, x liked the music, that is all that's governed by the universal quantifier. Why? Because the statement, it's not the case that Lm, it's not the case that I like the music, does not have any variables in it. It's not governed by a quantifier. It is really an almost unanalyzed proposition. It's just a proposition that's in there that's conjoined with the quantified statement. So everyone liked the music except me is that conjunction. Incidentally, one of the differences between the way I annotate these, the way I translate these, and the way some of these are translated in the book, is the textbook is more apt to add the predicate is a person. To my mind, unless there are conditions under which you really have to make that clear, is a human being. That proliferation of predicates complicates the assertion without adding any needed clarity. That's just my preference. Okay. Now, nevertheless, there are going to be some sentences about exceptions that qualify the subject a bit further. Everyone in the orchestra, but the first and second violinists, believed that the beat was erratic. Okay. So we've got two predicates that apply here. People in the orchestra and people who believe that the beat was erratic. My apologies, I don't know why I used the predicate T for believe the beat is erratic, but I trust that what follows is clear enough anyway. For all x, if you're in the orchestra and you're not identical with the first violinist, and you're also not identical with the second violinist, then you believe the beat is erratic. The first violinist does not believe the beat is erratic, nor does the second violinist. So we've got, again, a universal statement for all x. We've got a differentiation of the subject of that statement from the outlying cases. And we have a conditional that tells you something about what these people do. They believe the beat is erratic. Then we just conjoin the contrary facts that apply to the individuals in question, the first violinist and the second violinist. no one can pardon this crime except the governor. Okay. Again, there's an unstated implication that although no one other than the governor is capable of pardoning the crime, the governor, however, does have that capacity. Okay. So for all X, if X is different from the governor, then X is a non-pardoner of the crime, and the governor is a pardoner. Everyone is a non-pardoner of the crime except the governor, who is a pardoner. Now, this last example about something that no one can do except the governor takes the exception sentence and makes it negative. For everyone but the governor, pardoning is something they cannot do. And in these cases, we may equally well call the except sentences only sentences, right? To say that no one except the governor can pardon is equally to say that only the governor can pardon. So we might say in English, if you're the governor, you have the power to pardon, and if you're not, you don't, okay? Which is a long-winded way of saying only the governor can pardon the crime. Now, the identity relation only is needed in this rather small way for only and except assertions. We have to draw on identity more elaborately and often more tediously when we say at least this many, at most that many, or exactly this other number, okay? It gets tedious, and there are points at which you might get the locutions, the translations mixed up, okay? Because when you're talking about at least and at most, one of them uses a universal quantifier, the other one uses existential quantifier. In one, you don't assert identity, you assert non-identity, and you make a conjunction of non-identity statements. In the other, you assert identity and you make a disjunction of identity statements. So I guess if you wanted a mnemonic, once you've got one of those two, the at least or the at most, is once you've got one, the other one is different in every possible way. The reason we need identity in both cases is that, look, when you're saying at least 3, at least 4 objects with property A also have property B, what you're saying, you need more than one variable, incidentally. You need as many variables as you're asserting there are objects, okay? If you're saying at least 4 objects, then you say you need 4 variables. There exists an X, and there exists a Y, and there exists a Z, and there exists a W. So here we use the existential quantifier when we say at least. How to remember that? Existential quantifier reads as there is at least one X. Okay. So there's an X, and there's a Y, and there's a Z, and there's a W. But of course, the danger looms if you simply said, right, you want to say, there are at least 4 giraffes. Say there's an X such that X is a giraffe, and there's a Y such that Y is a giraffe, and so on. Of course, the danger looms that X, Y, Z, and W are all referring to the same giraffe. Okay, if you like, there are 4 names for the same object. So when you use the existential quantifier and you assert that there's an X, there's a Y, there's a Z, and there's a W, and then you say whatever you want to say about those things, you also have to specify that X is not Y, and Y is not Z, and for that matter, X is not Z, and Y is not W, and so on, right? So you have all of those non-identities have to be the case if you want to say that there are 4 different ones. Okay. Suppose we say there are at least 3 courses that satisfy the logic requirement. Fine. Now, again, they can't be 4 different names for the same course. 3 different names for the same course. You can't say, well, there's philosophy 77700, that satisfies the logic requirement, and there's the intro to logic, that satisfies the logic requirement, and there's baby logic, that satisfies the logic requirement. Those are 3 possible names for a single course. Okay, so that's not going to do it. You also have to assert that the X, Y, and Z are distinct. Here's what we're talking about. At least 3 courses satisfy the logic requirement. There's at least 1 X, and there's at least 1 Y, and there's at least 1 Z, such that what? X is a course, and X satisfies the logic requirement. And Y is a course, and Y satisfies the logic requirement. And Z is a course, and Z satisfies the logic requirement. And as I said, okay, we might be tempted to call it a day. That was the analysis we needed. We're all through, except that X, Y, and Z might all be names for the same object. So we need to go back and specify X is different from Y is different from Z, and X is different from Z. Now, if you only had 1 course, 2 objects, you're saying at least 2 things. And so there's an X and a Y. There's an X that's a giraffe, and there's a Y that's a giraffe. But you wanted to say there are at least 2 giraffes here. So you'd say, and X is not identical to Y. So when there are at least 2 things, you only need a single non-identity statement. When there are 3 things, you need 3 non-identity statements. Okay, so and you can see that the number increases because what you're doing for each of the objects, you're saying how many ways can it pair? Well, the first one, if you've got, let's say, 5 objects, the first one can pair with 4 others. The second one can't pair with the first one, that was done already. Can pair with 3 others. Next one 2, the next one 1, right? So you've guessed it. The pattern is when you have n objects, you're going to have to conjoin n times n minus 1 over 2 non-identity statements. Now, as I said, when you move from specifying that there are at least n objects of a certain kind, and you go to saying that there are at most n objects of a certain kind, every structural element of the analysis has to be negated. Pretty much everyone. Where you had an existential quantifier, you now have a universal quantifier when you're saying at most. Because when you say, for example, there are at most 2 loaves of bread in the cupboard, you're not committed to saying that there are any loaves of bread in the cupboard. You're just saying you don't have more than 2 loaves of bread. And for an assertion like that, you don't need the existential quantifier, which commits you to the existence of something. No, at least that says existential quantifier. So with at most, you want a universal quantifier. And with at most, you're going to make assertions of identity, not assertions of non-identity. And as I also said, you're going to use a disjunction rather than a conjunction. That's a nice symmetry. It only fails in one respect. When you say you're going to have at most n objects, you don't use n variables, right? When you said there are at least n objects, you used n variables. There are at least 3 courses that satisfy this requirement. You just need 3 variables. There are at least 17 mountain climbers in our class, okay? You use 17 variables. When you're saying there are at most n objects of a certain kind, you have to use n plus 1 variables. And there the idea is this. Whenever you've got one more than the number you're asserting, right? There are at most 3 guitar players here, okay? And so what the way you come upon it in English, what you'd say is this. You show me 4 guitar players here, okay? And I'll tell you that one of them is identical to at least one of the others, okay? So whenever you've got more than n, you've got some identity holding between one of them, at least one, and one of the others. So you're saying if you use the variables x, y, z, w, right? There are at most 3 of something. You use the variables x, y, z, and w, and then you're saying, well, then either x is y, or x is z, or x is w, and so on through all the combinations. 4 variables. How many combinations is that? In this case, you'd have 6, right? Yes. But when speaking of n objects, right, then you're going to have 6 identity claims. So it's not n times n minus 1 over 2. When speaking of n objects for at most, you're going to have n times n plus 1 over 2 identity claims. And that's simply because you added another variable. Here's an example. At most 3 people understand the theory of types. At most 3. 1, 2, 3, 4. Universal quantifier, right? So every time, whenever you have 4 entities such that X understands the theory of types, Y does too, Z does too, W does too, okay? Then it's going to follow that there's some duplication. One of those is actually the same as one of the others, whether it be X the same as Y, X the same as Z, X the same as W, and so on, okay? Now, you might observe, it's been observed before and widely said, this gets really tedious, okay? Why am I going on about it? Ordinarily, there are very few situations in which a sentence that says at least this many or at most this many needs to be spelled out with that many variables. And after all, when we say at least and at most, we're often dealing with much larger numbers. We're going to have to get at least 2,000 of you into this university. Okay, and X and Y and Z. Nevertheless, this kind of analysis has a real purpose as part of the project of defining mathematical terms, arithmetic terms. For starters, once you've got at least n concept, and you also have the at most n concept, then you can define the exactly n concept. And it's enough in these cases to realize that fundamental concepts involving number can be translated into logical terms that don't actually use numbers. Let me go back and show you what I mean here, right? At least 3 courses. There's no number 3 here. At most 3 people. There's no number 3 here. Okay, we have translated, well, long before us, Frege and Russell translated these fundamental arithmetic concepts into non-arithmetic logical concepts. Now, as I said, one of the nice advantages, one of the nice things you can do once you've figured out how to say at least n, and you've also figured out how to say at most n, is that you can combine the two and say exactly n. Now, just to go back to what I had remarked at the beginning of these comments, exactly n is a very simple concept in, I would guess, any natural language. To say there are exactly 3 people in the room surely does not require some long statement about how, you know, there are at least this many, and that means X is not Y or Y is not Z, and there are at most, and so on. So exactly n can only be analyzed with really quite a Baroque structure of logical terminology. I think we should all take our hats off to the analytic philosophers of the late 19th and early 20th century who figured out how they could restate such a fundamental everyday language concept as exactly this many into a logical concept. Okay, so how do we do it? Well, of course, what you could do is say there are exactly n objects such that so-and-so, and separate analysis, there are at most n objects. But if you thought at least n and at most n were tedious, then imagine the doubled tedium of saying exactly n. In this instance, there's a way of simplifying a little bit. You still have to do the entire analysis for at least n, but then you can just add a single additional variable and say, if there's even one more, then it's identical with one of those, okay? The example I've chosen here is there are exactly 2 perfect numbers less than 100. There are exactly 2 perfect numbers less than 100. This is true, by the way. I wouldn't say something false about perfect numbers. You may recall that a perfect number is a number that is the sum of all of its factors other than itself. So the number 6 has the factors other than itself of 1, 2, and 3. 1, 2, and 3 all go into 6. You add them up and they make 6. The only other perfect number less than 100 is 28, right? It has the factors 1, 2, 7, sorry, 1, 2, 4, 7, and 14, and 1, 2, 4, 7, and 14 add up to 28. Never know when you're going to need that information. Okay. There are no more perfect numbers less than 100. So we begin by saying that there are at least 2 perfect numbers less than 100. So there's an x and there's a y, such that x is a perfect number and it's less than 100. And y is a perfect number and y is less than 100. And now the kicker that makes them at least 2 is they're not the same perfect number. X is different from y. And also, yes. And notice, this is an important thing to notice. This and everything that follows comes within these parentheses after the existential quantifier x and the existential quantifier y. There are parentheses after the x and y, and everything falls within those because we're still talking about the same x and y that got their meaning from the original existential quantifiers. Okay, so we said there are at least 2 perfect numbers less than 100. Something is a perfect number and it's less than 100. Okay, and for all z, if z is a perfect number and less than 100, if we've got a material conditional here, if so, then you can bet either z is identical with x or z is identical with y, right? We've got at least 2. And this time we don't have to say, and there are at most 2. We've established those 2, and so we only have to add one universal quantifier and say, take any one of them, take any number that's a perfect number and less than, that should be an L, and less than 100, any one of them, it's going to be identical with one of the 2 that was already defined by the 2 existential quantifiers. That, incidentally, is why the parentheses have to extend to the very end, because anything else that satisfies those properties has to turn out to be identical with one of the 2. Okay, so at least the concept of exactly this many doesn't require the full machinery for saying at most. Okay. And now in what follows, we're going to be talking about something that's like a reduced or the most minimal version possible of this exactly, namely when there's exactly 1. Okay, that's how we've used identity to first elucidate more non-mathematical concepts like except or only. Then we used identity to make some sense of at least and at most, where that refers to numbers, quantities, and exactly. And now the kicker is, the reason we want to be able to say exactly, it turns out, so that we can say exactly 1. Well, for goodness sake, if we can formalize the concept of exactly 5, sure, of course we should be able to do exactly 1. Why does exactly 1 matter? Well, because we come upon the idea of exactly 1 when we use the definite article the. Okay, where the is used in the singular, it refers to something. The requires a level of analysis that quantifiers and predicates alone can't handle. Okay, that's the problem. That's the big picture. So, the picture of your grandparents. We're not talking about the predicate, the property of being a picture of your grandparents. If you want to say there exists a picture of your grandparents, okay, there you could just have the predicate, picture of your grandparents. There exists X, such that P of X. No, here we're talking about the picture of your grandparents, the pie I baked for dinner. And thanks to Russell, and this is the notation we find originally in Principia Mathematica. Russell used an inverted iota. And even though it's inverted, it's typically referred to as the iota. Iota x phi x means the unique object that phis, that has the property phi, the phi. We've got enough Greek letters going on. We can state this equally well as follows. The thing that f's, the f, the unique f, is referred to as iota x fx. In one sense, the iota functions as a quantifier does, like an existential quantifier, in that you always use it together with a variable. Okay, there's a big difference, which is iota x fx, the unique object that f's, is not a sentence. When you have a quantifier like exists, saying something f's, this doesn't tell you something f's, it doesn't tell you everything f's. It's referring to an object. Altogether, you can say this functions as a name does. Oh, I shouldn't go into this, but I would just say Professor Kripke's response to the theory of definite descriptions in his great work, Naming and Necessity, pushes back against Russell's idea that a name can be analyzed as a definite description. That's just a little teaser. If you haven't read Naming and Necessity yet, I recommend it. And it'll make a lot more sense once you know how definite descriptions work. Okay. Now, you might say, well, if iota x fx is just a fancy way of saying VF, the unique thing that f's, can't you just call it by a name, lowercase a? Why do I need iota x px for the pie I baked for dinner, when I could just give that pie a name? That's a. Well, of course you could. And often in logic, we leave things unanalyzed, just as in the first half of this semester, we talked about propositions, we symbolized propositions with individual letters, not analyzing them into their constituent parts, into the properties, into the relations among those properties. But it often happens in logic that the more you can analyze an entire proposition or a term within a proposition, the more you can discover about the logical relations among them, okay? And that's true with names. We could have just called this pie A. We call it the unique object iota x px, the unique object x that is the pie I baked for dinner, so that we can figure out what we're really asserting when we speak of such an object, and what truth claims talk of such an object commits us to, if any. Okay. So what does it mean to say when we're talking about the pie, what does it mean to say the pie I baked for dinner? When do we use the definite article? Well, in the first place, we use it when the thing exists. If I say a pie I baked for dinner is a special occasion, I'm not committed to the claim that any such pies exist. I might be hypothesizing that were I ever someday to bake a pie for dinner, it would be a special occasion. But the pie I baked for dinner, that term, the word the in particular, tells you that at least one such object exists. Now you see where I'm going with this. At least one such object. But also, because I say the pi, I really must mean that there's at most one such object, or to put it more plainly, there's exactly one such object, the pie I baked for dinner. So if I want to say the pie I baked for dinner is hot, I make a combination of claims. I really am making three claims when I say the pie I baked for dinner is hot. I write it like this, right? I just put the predicate H in front of iota x pi x, or px, okay? But the pie I baked for dinner is hot. But that's just the name of it. How do we analyze this iota x px? Okay. Very good. As I said, there are three assertions. There's at least one pie I baked for dinner. And there's at most one pie, which we can also say as follows. All the pies I baked for dinner are identical to it, to that at least one. And it's hot. Okay. So there exists an x such that p of x, there's at least one pie I baked for dinner. And now notice we're still within the parentheses, right? This existential quantifier x applies to everything until this final parenthesis. So there's at least one pie that I baked for dinner. And everything that's a pie I baked for dinner is identical to this same thing. So there's at most one pie I baked for dinner. And you know what? It's hot. Some of you might already see a slightly simplified terminology we might use for expressing this complex of relations, but to my mind, this is plenty clear enough and doesn't need to be simplified for our purposes. Okay. Now, I baked a pie for dinner. Let's say it's hot. The pie I baked for dinner is hot. And therefore, this is a true assertion. There's at least one pie I baked for dinner. There's at most one pie I baked for dinner, and it's hot. Suppose it's not hot. Well, okay, I can negate that sentence, right? It's either true or false that the pie I baked for dinner is hot. But suppose the joke's on you and I never baked the pie. Okay, there's no such thing. What becomes of my claim that the pie I baked is hot? Well, on Russell's analysis, we now see that that claim is false. It's not the case that the pie I baked for dinner is hot when the pie I baked for dinner doesn't exist. But that doesn't sound enough by itself. And now we're moving toward a philosophical conundrum. That was one of the reasons Russell needed to analyze and to come up with definite descriptions in the first place. It's a philosophical conundrum that some of you may recognize as dating back to the second half of Plato's dialogue, The Sophist, uh, when between sophists on the one side and Parmenideans on the other, philosophers are faced with the worry that they can't make any assertions about non-existent objects. How can you make an assertion about a non-existent object? Because you're describing something that isn't there. How can you assign a property to something that isn't there to, as it were, hold the property? Okay. How can you say, for example, that Santa Claus lives at the North Pole? Well, definite descriptions show us a way toward that analysis. Now, I just said Santa. I didn't use a description. By the way, I don't have an age limit on this, but if any little kids are within earshot, you might want to just be careful here, okay? Because there's some things about Santa and unicorns that are not for the young. Okay. What Russell argued, he looked at what a sentence like "the" implies. He said he uses mental telescope to look at what it must mean, and he found that when you're asserting anything about an object, you're implying an existence claim. Now, what Quine pointed out, and if you're interested in Quine's use of definite descriptions and the implied existence claims, I recommend his famous article on what there is. And one of the things Quine says there is that you can just translate any proper noun, any name, into a definite description. So Pegasus is the unique object that Pegasizes, and Santa is the unique object that Santas, where Santaing is just the property of being Santa, okay? So we can always, with that reductionist analysis, if in no other way, we can even put names into definite descriptions. Okay, so Santa Claus lives at the North Pole says that there's at least one X. Oh, sorry, I don't want that. I want this sentence here. Santa Claus lives at the North Pole. There's at least one X such that X Santas, right? That X is Santa. There's at least one thing that's Santa's, and there's exactly one, right? All the Santas there are identical with that one that's Santa's. And that object lives at the North Pole. By the same analysis, we can say the unicorn in my living room has a big horn. There's at least one thing that's a unicorn in my living room. And all unicorns in my living room are identical with that one thing. And that one thing has a big horn. Okay. Now, there's no Santa Claus. There's no unicorn in my living room. But by showing that these sentences imply a specific existence claim, that there is a Santa and there is a unicorn in my living room, I can now give those sentences a meaningful truth value, which is the truth value false. Right? The philosophical worry is that when you're saying something about a non-existent object, it's neither true nor false. You're hanging predicates on an object that can't have predicates hung on it. That's only an appearance, Russell says. Once you do this analysis of the, and you understand definite descriptions, then you see that even a sentence like Santa Claus lives at the North Pole, which on the face of it, grammatically speaking, contains no existence claims, even such a sentence does carry an assertion of existence within it. And for this reason, it can be called false. It can be called false even without getting into the North Pole, even without getting into whether there are other Santas. Just that first part of it, there exists at least one X such that X Santas. No, no, no. If there's no Santa, you now have a reason to declare that whole sentence false. So for philosophers, and again, this goes back to, well, in print, in writing, you might say, it goes back to Plato's dialogue, The Sophist. But the worry is already there before Plato in the poem of Parmenides, that the non-being, tomeon, can't be spoken of. Nothing can be asserted of it, even presumably that it doesn't exist. So you have a worry here, a philosophical worry, that there's no coherent way to speak of non-existent objects. And Russell presents his clarification, his philosophical analysis that for the first time lets us assign a truth value to such sentences. And by the way, I'm not going to get into all of it, but rest assured, this is still very much under discussion. Here's one way of getting at one of the problems. Suppose Santa Claus doesn't live at the North Pole, you may say. Suppose the unicorn in my living room does not have a big horn. Okay. How do we come up with the negation? Right? Santa Claus doesn't live at the North Pole. Do we take the analysis of Santa Claus lives at the North Pole and put a negation sign in front of it, as here? Okay, well, that was the unicorn, Santa. Now remember, this assertion, Santa Claus lives at the North Pole, we saw, thanks to the analysis, was a false statement. So by negating it, we come up with a true statement. It's true that Santa Claus doesn't live at the North Pole. It's true that the unicorn in my living room does not have a big horn. Have I just said something true about a non-existent object? A false sentence about a non-existent object didn't seem so bad, but a true sentence about a non-existent object seemed like kind of a problem, right? Well, the alternative, in the case of Santa, is not to put the negation out in front of the existential quantifier, which would make this true, okay? Here it's true that Santa Claus doesn't live at the North Pole. But the alternative is to put the negation here in front of lives at the North Pole. So it's still saying there is an X such that X Santas, and all Santas are identical with that X, right? There's a unique object that's Santas. And now you're saying, and that unique object, Santa, does not live at the North Pole. Okay. Well, now we're in the position of saying that's false too. So whether you're saying Santa lives at the North Pole or Santa doesn't live at the North Pole, you're saying something false. Is that where you want to leave it? Which way are you going to say it? Well, Russell himself had already noted that there are two ways of writing this negation. One of them he calls the wide interpretation of the denotation, the other one the narrow. I leave it as a final question to you to determine which reading is more natural. And think about it not with clearly non-existent objects, but think about what decision you would come to about objects that may or may not exist. If I did not bake a pie for dinner, and I say, the pie I baked for dinner is not hot, am I saying something true? Am I right? That would be a reason. That would be a reason, if you wanted to make it true, to put the negation out in front of the existential quantifier. If you thought, no, if you didn't bake a pie for dinner, you can't assert that it's not hot. Okay, then even that is false. And then you want to put the negation in front of the predicate is hot. Perhaps you find either alternative unsatisfying. Maybe you want to use other examples. Do you want to talk about Santa and the Tooth Fairy? Do you want to talk about pies you didn't bake, right? Or dogs you didn't see on the street? As I said, I'll leave that to you for further discussion and analysis. The problem of non-existent objects, if I may put it this way, isn't going away. But we can say a lot more about the difficulty of defining them and speaking about them now that we have the mechanism of the definite description. And we have the mechanism of the definite description once we define the two-place relation of identity. That relation alone, together with the familiar structures of existential quantifiers, universal quantifiers, and their logical connectives, are enough to give us this analysis of the. May be enough, therefore, to explain what non-existent objects are.